This meeting is being recorded.
Got it. I'd like to call this March meeting of the Homebrew Robotics Club to order. This is an astute occasion. It's the 20th annual HBRC challenge. I'll tell the story a little later, but let's see now. We were trying. Oh, I know. We were trying to get the order here, and let me share my screen. Not that screen. This screen. Thank you. And sharing screen. Okay. This is what I've got now. George, right? George, what's your last name?
Which George?
The George that's doing the demo, George.
George Taylor. George Taylor.
Taylor. Thank you.
Okay.
You probably just as soon give me your a ham radio handle, right? Okay,
Yeah.
George Taylor. George, what's your robot's name?
Oh, I hadn't named it yet, but it just take a second here. Let's see. Do I need to do a share or something here? Or,
No.
yeah.
Oh.
Oh,
Here. You see the schedule here on the screen?
oh, I see it. Okay, wherever I'm
I'm
down
sure-
at the bottom.
I'm sharing the screen, and
Okay.
you are. I've put you in here. Okay,
Okay.
you're right. You're right there.
Okay.
What's your robot's name? You got to give it a name, quick.
Roby Goby.
Roby Goby. Roby Goby. You like that? Roby Goby. Is that how you spell it?
That's right. That'd be good enough.
All right. Okay, we got you. That's 17.
Camp, I'd like to point out that there were also some people who mentioned they wanted to show off some robots in the news group. So if anyone who has a robot to show off, please type in chat.
Hang on a second, Chris. You're talking about in the mailing list?
Yes, there were some people that mentioned on the mailing list. So I just wanted to point out, if your name's not on the list,
hang on. I've been aggregating those names all along, and this is the list of the names. So if anybody volunteered on the HBRC mailing list and I did not capture your name, speak up now, okay? This is who we have. Okay, so we'll move forward if that's okay, right?
Camp, this is Ross. Am I on the list still?
Ross, can you see this list of names?
With two lists with NanoStore.
Yeah, you're up there at 6.
Yeah,
Okay.
number 6.
If you're demoing, look at the list, okay? If you're planning on demoing and you're not on the list, say something.
I am. Thanks.
You're very welcome, not a problem. All right, so we've called the meeting to order. This is our 20th annual HBRC challenge. I think the mailing list says it all. Let me just go to our homepage. And while we're there, I'd like to recognize our webmaster, Al Margales. This guy, let me tell you, he's a righteous dude. Last year we updated the website and he keeps this thing updated. And he's done a really great job. I'd like to give Al Margales a big round of applause. All right, there you go. Yeah, we've called this meeting to order. Okay, we're all clear on this is the order of events, right? We're starting off with table bots and then going to floor bots. And then it's mostly run what you brung. And that's okay because it is the Homebrew Robotics Club, right? All right. So this is the lineup here, and we're going to go through these 1 through 17. and see where that takes us. Again, keep it spiffy. So I'm going to stop sharing now, and let's see if there's some robot news out there. We got any robot news out there?
Well, this was the 10th anniversary of the founding of the Open Source Robotics Foundation. There was a nice note to that effect posted on the discourse.ross.org talking about all the cool things that have happened in 10 years.
Okay, so Open Robotics, 10 years old now. There's another anniversary while we're at it, talking about anniversaries, and that's Honda's Osmo is retiring, and it's been out there for 22 years. So pretty much the 21st century. Osmo, I saw it in Disneyland. Humanoid, I guess it's been surpassed by Atlas now. So there's that in the robot news. Any more robot news out there? We'll look in the chat. What's going on in the chat? We aren't on the list, but William said he added himself on the website. Okay, we're number 15. I will draw for my presentation. Oh, Sir Guy. Okay.
Hey,
Oh,
Cal.
okay. Sir Guy's got phone Wi-Fi problems. What's going on?
Hey, Cal,
Yes.
did you see where Boston or Samuel Adams Beer has been using the Boston Robotics in their advertisements?
Yeah, that was a Super Bowl ad actually, and I there's some other Boston Dynamics news here where apparently they're using Spot to guard Pompeii.
Hmm.
The ruins of Pompeii, quadruped robot in service of archaeology. So they've got Spot guarding Pompeii. I guess that's a good application for a four-legged robot.
Yeah,
Yeah, Captain,
definitely.
you happen to see the video where Spot goes by and there are two little dogs tied up who see it and just go absolutely crazy.
Well, I remember the one that TC is mentioning with the dancing. Boston Dynamics, they did all their dancing robots. Trying to get these in the chat here. There's one other bit of dog robot news, and that's these in China. They've got the robot dog out keeping people in line. I don't know if this is a good thing or a bad thing, but I don't know. What was it? What is it? They do in Terminator. What's the company in Terminator? Do you want? Come on, somebody help me out here.
Cybernetics Corporation.
Is it Cybernetics?
Skynet.
Oh,
Skynet. Yeah.
What's
You want
cybernetics?
Skynet? That's how you get. You want Skynet? That's how you get Skynet. All right. Anyways, any more robot news out there? All right. Let me see. Let's move on into club news. Any club news?
I've got some club news. Camp, can you hear me?
Yes, and see you too. Yes.
Okay, you can hear me and see me. It's magic. It's
Yeah.
amazing. Yeah, so just update on membership. I've got a number of people that have submitted their fees for 2022 membership. I've got a handful of people that requested badges, which is something new we're doing this year. Shipped out some badges today. I was a little late, but at least I got them out today. So, we're encouraging people to sign up. You don't have to, but it does keep our club strong. So if you think of it and you want to sign up, all the information is on the website. And yeah, I'll just leave it right there.
Yeah. Also, at some point, when we're getting together physically and go places as a club, as the Homebrew Robotics Club, it's required that you're a member in good standing to go to these events with the Homebrew Robotics Club. So there's another reason to actually pay your dues.
Oh, so that means I have 3 days to pay $10 to be at the robot block party.
No, because you're talking about, and this should be a robot news too, the robot block party.
Yes, that's
Okay.
this Saturday.
The robot block party in particular has you signing up as individuals.
Okay.
So, as far as I'm concerned, there hopefully will be a lot of home brewers there, but it's not going as the Homebrew Robotics Club per se, because you're signing up individually to have a table there and so forth, right?
Well, I mentioned she gave a maker code or a homebrew code. And so either of those are free, but I did mention I was part of the homebrew.
Let me tell you, DMS, anybody handing out discounts or anything like that, yeah, go ahead and sign up for it. That's fine. Oh,
A little late on the ball this year.
No, that's okay. You're doing fine. You're doing fine. No problem. No problem. Just keep building those in moves and so forth. Dee Dee's going to be showing us, I believe, the comedy show a little later, right? The robot comedy show.
Yes, updates.
All right, that's awesome. That's awesome. Okay, so yeah, and in the Tuesday Ross meetings, I'm going to put something in the chat there. I've been going crazy over this Lino robot project. I know that Mark Womack started a list some time ago for a robot example, HBRC example list. And I think Ross Lunan mentioned this back in November, but this is really a neat package, this Lino robot. And in the Tuesday Ross meetups, at least I'm going to be talking a lot about the Lino robot. So there's that. What else? Any more club news? Any more robot news?
Yeah,
it's sort of robot news, but I had a question for Jim about the Robot Society of Southern California. Because I recently moved down to Southern California, I was wondering, were you guys planning on doing live meetings? I heard rumors in that direction recently.
Yes, you can hear me? We resumed our meetings last month, and we're having the next one on April 9th, Saturday at 10 a.m. at the University of California State Long Beach. And the details are on our webpage, and it's going to be joint online and in person. So we've gone through that once. We have a nice 360 camera, and it seems to be working for the people online as well as the people in person. We send, if you're interested, anyone, please join our Google Groups mailing list, and that has the Zoom link and the full information that will go out next week. It's also on the top of the webpage, rssc.org. So yeah, welcome to the region. Where did you move to the? Did you say you're down in the area, Southern Cal now?
I don't know how close I am, but I'm now in Laguna Niguel.
Oh, okay, yeah. Well, I'm in Newport Beach, and I drive up to Long Beach. It's in Long Beach is where we meet. So we have other people coming. We have at least one other person coming from Laguna Niguel area, maybe more. So you're definitely welcome. It's a new location. We've only had one meeting there in this nice building that is actually part of the facilities management of the university, and so they've graciously provided the space for us with a really nice projector and the internet or the camera for showing for broadcasting and all that. So yes, there it is, and there's a link to our mailing list as well, right near the top, but it's a Google group. I can paste it in the chat.
Hey, folks, I'm having problem with the video on my computer, and I normally get screenshots through this thing so that we can post them later. Is there somebody out there that can do screenshots as we move through this thing? Maybe even two people?
I can.
Okay. Yeah, just do the screenshots as we go along. Like I say, each presenter, we'd like to get a glamour shot of the person with the robot, and then we'll post them later. That'd be super. Can we get another volunteer to do screenshots so that you can't take enough pictures? It's easy enough, you know, function print screen. That's on Ubuntu. Hello, can I get somebody else to take some screenshots out there?
Oops. We're getting some feedback from somebody, or not feedback, but machine noise. Please mute your microphones if you're not talking.
Hey, Al, can I get you to save screens? Al Margales?
You're muted, Al.
Okay, somebody, I am on a new setup, you know.
Hi, this is Two Flower. This is my robot. A few years ago, it's getting on about 5 years ago, I started building this robot using a couple of different pieces
What?
of software,
We need to
mostly
be
robot
meeting
operating system
somebody.
called Ross,
Who's
and
that?
Who's that?
Package from Parallax called the Arlo Bot robot system. So sort of a conglomeration of a lot of different pieces. That
Somebody's playing a video.
Half a decade in order to make a robot that can navigate a room.
Who is that?
Start out here with a quick view of the robot up close, and in a minute I'll show you a little more of what it does from a distance.
All right, is that done? I am just a different piece of club news. I am using the club sound system and the thing called Open Broadcast Studio, testing out the configuration to do in-person meetings. And I don't know what effect that has to all my normal features. So I'm a little nervous about taking the pictures. You know, come on, somebody, one of the other officers. Not that hard.
We'll try to unmute myself here. Somebody volunteer to take the
I can take
screenshot.
pictures. This is Scott. I can take pictures.
Super fine, Scott. Appreciate you volunteering. Okay, we're gonna move ahead here. So we've done the robot
hey.
news. Yes.
Hey, Camp, I do have another club news item if you want.
Please.
So our next, speaking of the next RSSC meeting, we have a special guest, Chris McKenzie, Mike McKenzie, who's a Samsung research person who has been instrumental. He's the author of the NAV2, the famous NAV2, one of the main authors, and he's on the on a ROS. He's in the ROS core development engineer.
You heard Steve McKenzie?
Steve McKenzie, yes, sorry. So he's going to be talking virtually.
He's the man, right?
What's that?
He's the man, isn't he?
Yeah, I mean, I haven't really heard it. I haven't really listened to his talks yet, but many of you probably have who are involved with ROS. And so he's done several different ROSCon and other events. And
he
so
basically ROS too, if I'm NAV2, if I'm not mistaken.
yeah, he's like the primary author. So he's going to give a talk about the architecture and what else? The architectural configurable aspects, algorithms, and show demonstrations of new capabilities in NAV2.
When and where is this, Jim?
So April 9th at 11 a.m. is his talk, and same place as I mentioned. Go to rssc.org, sign up for our mailing list, and we'll be sending out the Zoom link for those who are remote. And in person is in Long Beach, Cal State Long Beach. That information is
So you're
online.
going to send it to your mailing list, the link?
Yeah, so the Zoom link is sent every the week before the Saturday, which will be next week.
Yeah, that's the Robotics Society of Southern California, the RSSC. Jim Denugio here is the president, right?
Yeah, I'm vice president this year. We swapped. I swapped with Ben Partisi, who's president this year, but we're both doing we're both doing the duties.
Okay.
Anyway, that's
April
thank you.
9, 11 a.m. Pacific time.
That's Pacific Daylight Savings Time.
No, we're in the we're in the daylight. Okay, sorry, you're right. Okay, moving ahead. Thank you. That's big news, Jim. Okay,
Yeah, I'm glad I got him.
yeah, that's huge. Moving forward, let's see. This is a special meeting. This is an all show and tell meeting. In 2003, a group of us were meeting at the Castro Street Middle School, and we were lamenting the lack of robot building in the club, and observed that building activity coincided with contests. We've done a line following contest, a maze busting contest, and people built robots for it, but they showed them one time and put them on the shelf, and that was kind of the end of it. We were lamenting the lack of building in the club, and bear with me. We were meeting at the library, and there were tables all over, and it's like, oh, we didn't want to have to set anything up, and we wanted to use the robots that we had. And so we decided we'd play tabletop soccer. We'd put nets around the table and so forth, but that would be set up. So that's when it was born, the TableBot. A TableBot is a robot that survives, survives, lives, and plays on the table or pays the price. We still wanted to do tabletop soccer. How do you get the tabletop soccer? Well, the same way you would eat an elephant, that is one bite at a time. Ching. We decided to do it in phases. So in the months of June, August, and October, we would build the robot in phases. Phase one is have it go from one end of the table to the other and back. Phase two, have it push a block off the edge of the table. And phase three, have it move it into a shoebox mounted into the table. We didn't specify the size of the table, the size of the robot, the size of the block. I've seen some awful big shoeboxes over the years. But we just had, and it's not a contest. With contests, you got winners and losers. Gosh, your tape was too shiny, or my gates were wider. So we decided not to make it specifically not a contest, to make it a challenge, to make it a show. Again, over the past 20 years, we've had a lot of fun with it. And then the very next year, we changed it to be the HBRC challenge and added in the Floorbot challenge for the robots that are too big for the table, and the Armbot challenge, LineBot challenge, Robo Magellan trials, and also this Run What You Brung. The idea with Run What You Brung is we are the Homebrew Robotics Club after all, so you're building your special one-of-a-kind robot. And the idea is to show up with something finished, okay? Our stock and trade is finished robots, but works in progress are good for partial credit, we say. That's where you're to show up with your robot in some state of finished and enunciate your stage, your phase 2 and 3 goals. We do this again in June and October. Okay, we've changed the dates a bit, but it's basically now June, or I should say March. This month is phase 1. and June. So if you're doing a run what you brung, here's the thing, is you're supposed to show up with it as a finished robot. I can understand my robot's not finished. It's not phase one. It's still a work in progress, but you want to get it to some kind of phased one, some kind of state of finished. Then you want to enunciate your stage 2 and 3 stages. After all, robot building is never done. You'll want to add something and then add something. And so the concept is without a deadline, nothing happens. So you have this deadline in June to build something, and then, or I should say March, and then June and October to get to phase 2 and get to phase 3. It never works out this way, but at the very least, you've got a deadline. It makes you do stuff. I don't know about you, but I did stuff this week that if we didn't have this meeting, I wouldn't have done it. So, you know, we do stuff because we have the meetings. And so this is why we do it. Without any further ado, let's get this show rolling, because the show and tell is the show. Let's see here, going to the screen. So first up here is Mark Womack. Mark, you out there?
Yes, I'm going to switch.
Okay, let me share my screen. Mark, what you got?
Hold on a sec. All right. You guys can hear me okay?
Yep.
Yes.
Okay. So this is my famous Butcher Block Stadium. I'm going to be showing off Beatrice here for the Tabletop Challenge Phase 2. And just a quick show here. This robot is basically like all sensors. It's got line following. The 4 that are out there are edge sensing. These ones right here, these time of flights are for distance. And then it's got this one board here. It's using a Teensy 3.5 for the microcontroller. Oops,
Can I hold up for 1 second, Mark? Dee Dee and Scott, you might snapshot some pictures as we go through this even, right?
Here. Yeah, absolutely. But I'm going to bring up the robot for the selfie here.
Okay. Dee Dee?
There we go.
Yes, I'm screenshotting.
Okay. Yeah.
Okay,
And
good.
And we are recording, so you can pull the screenshots right off the video if you like.
Right.
Very good.
So it's got a Teensy 3.5. It's got a bunch of power stuff here. It's using a Pololu motor driver. I actually hooked in a ESP32 Wi-Fi thing there, so I could do some debugging through UDP on my laptop. It's using a regular USB battery brick. It's got a couple buttons here. So this one is gonna turn on the robot. Well, second push turns on the robot. There we go. And it's using a NeoPixel here to kind of show what its state is. So right now it's like in an idle state. It's ready, and it's ready to go at this point. This is phase 2. I already sent the video for phase 1. Eventually I'm going to have this button here. I'm going to have all the programs in there, and I'll be able to use this to choose which phase it's going to be executing at any given time. But right now it's only phase 2. All right, so I've got a, I don't know, Dalek, whatever you want to call that. And then it's going to go ahead. I'm going to push this button here, and it's going to hopefully find it. I'm going to put it a little closer so the first ones find it. So you saw it in the beginning. It does a little happy dance here. You saw in the beginning, it kind of did a little bit of rotating, and then it kind of did a little jig as it sensed that the object was there. Now, if I put it to the side and hit the button to start, eventually it finds it. And, oh, there we go. I can do one more where it's further away. So then it kind of goes into a pattern. Hopefully this one will actually find the pattern. Let me give it a little bit of an angle. So it didn't find it, so it's kind of moving to a different location. It found the edge, so it's like I got to move away from the edge. And now it found it. One thing about this robot that I tried to do, it may not have been, so I've flashed it up so quickly, is I tried to give it symmetry. There's a line of symmetry for the robot for both the line following, for the edge sensing, and also for the distance sensors. There's actually 10 of these distance sensors all around there. So right now I call this the front and I give it some priority when it's trying to push off the object, but eventually I'd like it to kind of be able to do bidirectional, like wherever it sees it, it moves the back to it or the front to it, whatever, without having to spin around.
There's some questions in the chat. Question, are you using the time of, what are you using for the time of flight sensors? And is that a Lidar or ultrasonic to see the container?
I think it's those ST VLX 6180s. So I guess those are, I don't know. I guess those are Lidar, they're the, these guys here. Well, there.
Okay. Oh yeah.
Yeah, so. Yeah, the ST Electronics ones. These are these actually only see about, I don't know, about 100 millimeters out. I've got the other ones where they can see like way out, but I didn't put those on there.
I believe those are time of flight. I may be wrong there. Anyways,
they are time of flight.
Chris, Mark, do you want a rating? Do you want a certification rating?
Yeah.
Okay, Chris Mayer is our certificationator. What say you, Chris Mayer? Is that a phase 2?
That is a successful phase 2 accomplished.
Yay.
Mark down as a phase 2. Can we get one more glamour shot there, Mark?
Sure. Let me flip it around here and where'd my camera go? There we go.
There we go. Okay, get your head closer. There we go. Okay, that's a good shot. Okay, thank you very much. Mark Womack, ladies and gentlemen.
Thank you.
All right. Thank you. All right, I'm going to go next. I've got a table bot, and let me turn on this light here. Chris, can you spotlight me? Thank you. Okay, this is Buggy. And Buggy shall attempt a phase 3. Ta-da! Thank you very much. Let's try it again. I know you couldn't believe your eyes. Ta-da! And let's do it one more time.
That's an official phase 3 accomplished.
All right. Oh no, missed the goal. I should have quit while I was ahead. Oh well, that's the way it goes.
Okay, I'll give you 2.5 for that.
Hang on. No. We're gonna recover here. No, I'm not. Okay, I should have quit while I was ahead. You did see, I did get a 3 though. I did have a 3. Okay, next up, I'm gonna do my table bot here. And let me share the screen. Come here. All right. Now here's my bot back, and I've got some teleop twist going here. I'm going to drive out to the other room and go from one end to the other. This map is really crappy, but I think if I get out there, I can get a one end of the room to the other. Okay. Let's see here. So let's see here. I'm going to turn the video around. And let me go back here and share my screen. Okay. So here's the robot here. Can you see the robot okay? Yes?
Yes.
Okay.
Yeah.
Okay. Let me drive it over here. Al, how am I doing on time? So here comes a Floorbot challenge phase 1 attempt. I'll go from one end of the room to the other and back, okay? I'm going to do it with nav2 and these waypoints. I'm just setting the waypoints in there. Al, how am I doing on time for this robot?
You're coming up on 4 minutes, but
For
that's
this robot? Okay,
two
here we go.
robots.
Start navigation. So here goes the robot, and you can see him navigating there. So I think I hear you saying I got a minute, right?
Yeah, at least.
Okay, here you see the robot navigating. Okay, nothing up my sleeve. And there's the robot moving live. It's a physical robot. And RViz, of course, is the visualizer. So that's one end of the room, and here he comes to the other side of the room. Yeah, Scott, this is ROS 2, it's nav 2, and they have waypoints that you can put into your map. And you just set the waypoints, and the robot will go from one waypoint to another. So there it's gone from one end of the room to the other and back. Chris, what say you? Is that a phase 1 Floorbot?
That's an official phase 1 robot for Floorbot, yes.
Okay. So I got now on Buggy. Are you going to give me my phase 3, or do I have to settle for phase 2.5?
No, you got the phase 3.
Okay. This will be recorded for all posterity. Okay. Phase 3. And then on my Floorbot, I've got a phase 1. Okay. This is another robot. Okay. Sorry, guys. I get 5 minutes per robot. And this is my Robo Magellan robot. Al, start the clock. Okay. So I've got, I won't bore you with the whole video. That's Kerbit. Kerbit the robot. It is Kerbit. Kerbit's my Robo Magellan robot. I was thinking it was mini Kerbit.
We're still looking at your Floorbot, Camp.
Okay, thank you. I'm going to thank you for that. Let me come back here and do there and there. Come on. And that's not what I want. What I want is my YouTube. Okay, here's my Robo Magellan robot. Now I don't have the sound on there because I've got the sound on my phone, but anyways, this is a regular GPS. It's really pretty bad, but again, I did things with it that I wouldn't have done otherwise. And so that's the goal of these things. I've got two Arduinos. One reads the GPS and tells the other Arduino what to do. The other Arduino drives the wheels and reads the sonars. And so my target GPS coordinates up there with the orange cone. I don't have a camera on board yet, but the GPS gets you in the ballpark. GPS is good for 15 or 20 feet. So, it'll get you into the ballpark. And as you can see, he's kind of sort of headed in that direction. Let's go out a bit. Yeah, here's where he drops down in and he backs up. That's obstacle detection. I actually got close to the goal at one point. Let's see if I can find that. Come back. Yeah, here's where he gets stuck at the end. That's made with a Huffy Green machine. It's a kid's toy. And I need to put some bigger wheels on it so I get more clearance. But I think it's a pretty good chassis. Like I say, the GPS gets you in the ballpark. You need the orange. You need the camera. I've got a Pixie Cam that to do the rest of it. So
so are you using the motors that came with the
yes.
green machine?
Yes, I am.
Nice.
Yes, I am. Let's see here. Here's this. And okay, so there's that. Okay. So, and I'm working out. Can you see my, I'm working out the, actually I could have him pushed it off. I've got a Pixie Cam and I'm working out the orange component where when the GPS puts him in the ballpark. So I'll put this at the nose of the there, he's got a phase too. I'll put this in the nose of Kerbit so that when he gets into the zone, the orange finds the orange finds the I should say the Pixie Cam finds the orange and drives him on into the goal cone.
So I'll
And
be
then
sure,
finally,
I'll be sure to wear my orange sweatshirt when you do that.
That's an old trick. And there's a story behind it. I got one more demo. So Al, if you'd start the clock again and let me know when it's at about 3 minutes, okay? And that is the smart table, okay? What I'm gonna do is I've got my bot deck that I did the mapping and navigating with. And this is a TurtleBot 1 superstructure that I built that you can just mount in here. You see, and there I've got the ultrasonics and the camera. Now I'm working without a net here. So Al, how am I looking on time?
You're just at 30 seconds now.
Okay, thank you. Because I didn't set this up, but what I've got is I've got my map that I created earlier, and I can set my pose, which is back here. Okay, and let's just navigate out a bit and let it got too much weight on it. Let's see here. Okay, there we go. And so I can do this 2D nav go and just have him go backwards there. And okay, so let's go back to my cheat sheet here. Where you going, robot? And well, he's into something now. Let me back him up. Oh, that got delocalized badly. I'm about here. Okay, and I'm going to navigate to here. What? Okay, you get the concept. So what I want to do is turn on the Lidar and turn on the camera. How much time do I have left, Al?
You're about 2.5 minutes now.
Okay, so I got 2.5 minutes.
Yep.
I think I can do this. Sorry, I should have had this set up.
Isn't there supposed to be like a martini or something on top of the table?
That's like phase 1.5. Okay. Here's the Pi, Raspberry Pi I call Smarty Head. And I set the frame at 5 frames a second, which is plenty adequate for remote viewing. This doesn't do any navigation or anything. And I run the video for Linux driver. I'm gonna have to log back into Smarty Head to run the RQT image. RQT image view. Okay, and then finally, my Ultrasonics, which we created at the ROS 2 discussion group. Basically, it's from Ultrasonic Raspberry Pi Python program. And we combine that with the ROS 2 tutorial that did Hello World, simple publisher. And we turned that into a range type message, and you'll see our cone on here. I've got to go back here. How am I doing on time, Al?
Yeah, you've got 15 seconds in your official time.
Okay. Okay, so now I've got the topic. I've got the ultrasonic topic running. You can see that, okay? And put that right here. I've got the camera running. I should have the camera running. Okay, time's up for that. Oh, there's the camera. It's not running. But time's up for that. And I've got the well, I don't see my cone on there. Anyways, so basically I've got a functioning ultrasonics, and generally I can get the cone in the RViz. I'm sure I could if I relaunched it, but I'm not going to take time for that. But I'll back him up and go forward, and you can see the change in the ultrasonics. Okay, let me stop this thing. And so that is a work in progress. I know that, so I won't ask for a certification on that, but that's the smart table. Let's see, I see a question in the chat. What is that? The field of view for the ultrasonics? It's a set amount. You set the minimum distance and the maximum distance, though. Yeah.
Yeah. I was going to say the ultrasonics, I think, you know, they're generally 30 degrees. And my real question sort of there was, is that something that you had set in there or that was already built into RAWs for ultrasonics, or if it was magically calculating that somehow?
The only specifications that I spelled out were the minimum distance and the maximum distance. And I've had some issues with the URDF and I'm wondering if it has to do with the distance that I set. But anyways, I'm playing around with that, and I'll post to the mailing list, and maybe we can pick up a discussion on it. Okay, so let's see where we are. Bear with me. Boom. Switch. Okay, who's next? Who's next?
Hey, Camp,
Yes.
this is TC3. I got an issue I have to take care of, so I'm
No
gonna
one
have to
volunteers,
go.
Camp. I've got a couple of videos I can share.
Sorry.
TC, are you saying you've got to head out?
Yeah,
Okay, can you do your demo right now and then we move ahead? Yes, no, maybe?
We might have lost TC.
Okay, that's okay. Mike Ferguson, you are
We
up
lose you,
next.
Camp?
Stop.
Okay.
Oh. Sorry.
That's okay.
I had my speakers all the way off. I had to switch systems. Sorry.
Ralph Hips, ladies and gentlemen.
Oh,
Mike
okay.
Mike Ferguson, you out? No. Hang on, not so fast.
I'm here.
What?
Ready to roll?
Yep.
What are we doing?
Hang on a second. Ralph looks confused. I want to just straighten one thing out real quick.
Oh yeah, you're gonna put the list in the chat so we can reference it.
I'll put the
Mike
in the
Ferguson.
chat. It's a great idea, Dee Dee. Okay, but this is the list, okay?
Oh, okay.
And I'm putting that in the chat.
Cool.
And Mike Ferguson,
Yeah, can you hear me?
we can hear you.
Yes.
Okay, awesome. Can you see the room? I guess. Hang on, it looks like you're still spotlighted.
Yeah.
Camp.
Can you spotlight Mike?
Share.
There we go. Cool. Yeah, so this is the UBR1. For those of you who don't know about this robot, I actually designed this in a company that was a spinoff from Willow Grove. And then as with many startups, it went underwater and died. And then back at the beginning of the pandemic, it turned out that the robots were for on Craigslist from the people who had like put them in a storage unit 7 years earlier. And so I managed to buy them off Craigslist, and I've now got the robot running both ROS 1 and ROS 2. Tonight, I'm just running ROS 1 because I'm having some problems with my ROS 2 setup. So,
Hey, Mike, can we get that glamour shot?
oh, like that.
Thank you.
Dee Dee, Scott, you got it?
Yes.
I got it.
Awesome. Okay, so I'm going to give it a command now. And so I guess this is like the Floorbot level 1. So it will actually go all the way back down to the other end and come on back. And so, yeah, so this is running ROS 1 navigation still, although my setup for ROS 2 is about the same. It's just currently broken. So I guess it's not exactly the same.
So did I see you go from one end of the room to the other and back?
Yeah, and it's actually just on a loop, so it's going to do it a couple of times.
And that
Yep,
is
that's a
lot.
Floorbot phase 1 completed.
Yep.
Okay. Our
So-
certificate originator, Chris Mayer, ranks that a phase 1 table bot success.
Cool. Yeah, so that's kind of all I had for that. I pulled the robot out, got it running, found some bugs and some things, and actually got the bug fixes earlier tonight. So that's always nice. But yeah, I don't.
So you know what phase 2 and 3 are of the Floorbot challenge, right?
I think I got to pick something up at some point. But
Phase,
I have not.
phase 2 is to find an object in the room, and phase 3 is to fetch the object.
Okay. Well, maybe later this year.
June.
Awesome.
That's excellent.
That's all I got. So
thank you. Ladies and gentlemen, Michael Ferguson. Thank you very much, Michael. All right, let's see who's next. Tick tock. Michael Ferguson. TC, I think left us, and he's got Arlo, so we'll have to get him on show and tell next month. Next up, Ross Lunan. That's Ross with 2 S's.
Two S's. All right. Hey, Mike, nice to see you online here. I got fond recollections of seeing what you were doing 9 years ago with your arm picking up blocks off the table, and then with the what you just showed us. That's time goes by. Today I'm showing my nanosaur, which I can do by doing this.
Hey, Ross.
Yo.
Before we get too far into it, or if you want to later, that'll be fine. Can we get the Glamour Shot?
Yeah, I'll do that at the end because it'll involve picking it up. And the last half the time when you do that, it dies, and that's not a good thing. So here we are. All right, so there's my lime green nanosaur. The design was created and developed by experienced robot experimenter, actually in Italy. He used to be on his own, but now works for NVIDIA, peddling all their stuff. It's an open source NVIDIA Jetson Nano 2G, built on a 3D printed printable chassis and designed to wander around on the table. It's been great for me to learn fundamentals of ROS, and the developer is adding code to do NVIDIA Isaac, which is accelerated vision, and ROS gems, so that you can learn how to use AI applied to robotics. It's quite neat. It has as I'll show in a moment. He's written a whole lot of scripts that make interfacing with the stack a whole lot easier than it would be otherwise. Some of you already know that you can't run Foxy 2 on a Jetson Nano natively, so it uses a Docker container that has compiled ROS to Foxy inside, and it's pretty neat. I got it running here strictly with my joystick on the floor. That's a camera on the front, fisheye lens, and the developer is working on adapting that to do some SLAM. And that'll enable me to navigate using RViz.
So you're just driving it around now, right?
Correct. It's not autonomous, but this is just the platform, and it's been great to work with, just with all of the pieces that come out of the 3D printer and put together, which actually I can show it in just a moment here. So I take off the stop share, get rid of the picture, go back to share. So what I'm going to bring up now is the this is my desktop, my virtual, actually it's a virtual machine inside on top of my Mac. Up here is the terminal for the desktop, and this is the desktop, right? So it's SSH. Sorry, this is actually my desktop. So if I do a ROS version, it's ROS Foxy, and then I just did a ROS node list that shows all the different things that are running. This is the coolest part of the design. This is a node that's running on the Nano, on the robot, It's called Ross board. It's a web GUI for the robot, and you can pull up a whole bunch of topics to look at. And the coolest one, of course, is the camera. What did I do with my joystick? Here it is. It really does work. Getting the camera to run on Ubuntu 20 is difficult, but there's code actually built into the Jetson Nano, the V4 L4, I guess it's called V4L2, that ports the video signal out so you can see it. Creates the video message, which you can of course display as a on
I just shared the link for that Ross board.
Pardon me?
I just shared the link for the Ross board.
It's pretty neat. Okay, and then last thing I guess it's interesting to show is this. Okay, so I've SSH'd into the robot, which is actually SSH'd to a running Ubuntu. The developer has created a script that lets you find out all kinds of things about it. So if I just type nano soar AUR info, it comes up with, it tells me what's inside the container. This is the nanosaur core itself. This is some kind of a, well, it says watchtower, it kind of watches things, and this is the web GUI. And here's the requisite configuration that you would expect in a running ROS device. And then the last thing, the question is going to come up, well, how do you work with the code? How can you tinker with what's in the workspace? Well, you first of all have to enter the container by doing this. And this is actually running a huge script that does all the things that give you access to it. Again, this is SSH right into the robot right now, and you'll see actually you'll recognize the sourcing command that comes up, and I now have a different command line that's actually the root of the device, the root of the robot, and I can do so. You're actually looking at the workspace as it says. If I CD into the source and do a list, right? So there's actually the robot code that that's actually running the robot. Now
let's get the glamour shot, Ross.
Okay, good. I'm done with that. There's one last thing that's worth mentioning is that, okay, so you actually can't work inside the container without rebuilding it. So the designer has written a script so that you can actually work on a workspace on the outside the container on the robot, mess with it, tinker with the code, and then rebuild the container and go back in as I'm showing here. So let's get the robot and do the Glamour shot. Which I'll do by doing this.
That's our screenshot, folks. You got the shot. Hold the robot a little higher, Ross.
No, just a minute. I'm going to. I have to pull up this.
Take your fading background off. It's fading out the robot.
That's right. Yeah, that's right. Oops, not stop it. There we go. That it? Okay.
Give that to us one more time. There we go. Looks good. Let's see those beautiful eyes on that robot. Yeah, that's the stuff.
There we go.
We're talking about Ross's beautiful eyes.
Yeah, no, don't blur them out. I'll do it like that.
From Canada, ladies and gentlemen.
Nanosaur. And while I've got it in my hand, I guess I'll just show you some of the other pieces. There's a battery on the back, 5-volt battery. the connections to the GPIO up front. And this is kind of neat. If you open up,
This is run what you brung. Do you want a certification on this phase 1, 2,
there we
or
are.
3?
Motor driver and the camera on the inside.
Ross, do you
Nice,
care
a
to
nice
have a
package.
certification on this?
Phase 1.
Well, okay, that's up to Chris. He's gonna make the call. Do you want to
We don't
certify?
certify run what you brung.
It's a
okay.
certified run what you brung?
I guess
It's
it is, yeah.
self-certification for run what you brung.
Okay, that's phase 1. It's a finished phase 1, and we'll move on from there. Scott Horton, you're on deck. What's up?
Great.
Thank you, Ross.
Thank you very much. Thank you.
Hey everybody, this is more Elsa Bot stuff. So I've got a video I'll show you. I put together last night, so hopefully it'll tell the story. Let me find the video here, so I can get it separate. I'll just do this desktop. I don't know if you can see. Let's see. What, can you see the video? Okay. Should I make it bigger or is it okay?
It's okay.
Okay. Just to know, to see what's going on here. This is Elsa Bot. I've showed it before. Showed Elsa Bot before. I added a little 6 degree of freedom arm on the front of it now above the Lidar, and a few windows over here. A couple of RViz instances. One showing the robot arm part of it. This one's just showing the map. And then over here, these are video feeds from Elsa Bot's OD camera. One of them is just the color camera, and another is a view of the detection that's doing. So the gist of this demo is Elsa Bot uses their OD to do the detection of the balls, to know where to see them and to know where they are on the floor, and then use the arm, then move to the balls, pick up the balls, and put them in the bin. So I'll get this started.
Scott, let me hold you for 1 second.
Okay.
Dee Dee and Scott Monahan, are you guys capturing images as we move through this?
Yes.
Okay,
Yes.
cool. Thank you. Go ahead, Scott. Horton.
All right.
I see 3, moving to the closest ball. I'm at the ball. I'll pick it up now.
Some of the arm motion
I'll
playing,
get to the ball then now.
it's kind of slow. I think I'm going to switch to the IK Fast plug-in instead. Hopefully that'll make it a little faster given the CPU available.
How much does Elsa Bot weigh?
Drop it in.
I have no idea. It's getting heavier and heavier.
Nice cat cameo.
Back to the pickup area.
Boris likes to get involved with my projects.
That is an official robot arm challenge phase 3 completed.
Oh, okay. So I'll stop it there because I know other people have more to show, but there's 3 more of those iterations. So that's the gist of it. I mean, just got it working last night and threw together a video, and the plan is to use this thing to actually pick up a bunch of these balls downstairs where the grandkids play. So this is just kind of the first phase. I need to improve it to where it's more accurate and, more robust, but that's it. So
Chris just gave you an arm challenge phase 3, and he doesn't hand those out freely.
okay, well, thank you. And
I'm a little disappointed that the cat was not impressed, but I'm impressed.
Usually the cat just lays on the floor with its head and yawns. So, but yeah, the code is up on GitHub, my GitHub account. So if anybody's interested in trying to use any of it, I tried to structure it using the behavior tree framework that I was using last year for the Elsa Bot project originally, and so kind of building onto that to where it's more reusable. So I've got some refactoring to do to make it cleaner, but hopefully it'll be something that somebody could say, hey, I could use a little.
Perhaps you could put that in the chat. Chat.
All right, we'll do.
Thank
That's
you.
all I've got.
Very nice.
So,
How's the best way to get a glamour shot here, Scott? Is Elsa nearby?
yeah, let me turn this off real quick. I don't make good shots, but let's see if
Go down a little lower.
Okay, how's that?
Scott, Dee Dee? Oh, the cat, lovely.
Got to get another one with the cat now. Hold on.
My camera's a little blurry, so I hope yours is better than mine.
All right, that's the best we can do. It's the best we can do. All
Got it,
right,
got
ladies and gentlemen, and the Elsa Bot. Thank you very much.
And Boris, yeah.
Oh, that was awesome. Jim DiNugio, Big Orange. What's up, Jim?
All right, yeah. I'm gonna switch over here to my. All right, can you hear me?
We've got a lot of feedback from you, Jim. Sounds like you have two microphones going.
Okay, how's this?
Much better.
Yeah, you have to turn off everything. Okay, so I'm taking my mobile camera here so you can see. Big Orange has.
We can't see. We can just see your chairs.
Yeah, we're looking through the computer or something.
I'm on a second video.
Oh, we see it now.
Yeah.
Now we're good.
So Big Orange, I gave it a, I've probably seen this already, but the Respeaker array device is on top here, and it's got, so this is a microphone array called Respeaker V2 version 2, and I made a case for it, 3D printed, and so it's really cool a speaker array or microphone array that can determine the direction of sound, and it displays this pixel ring, and you can control it, and it has a voice detection circuitry or system, as well as active noise cancellation, all sorts of cool things. $64 off of Seed, SEEED Studio, and I'm using it here to be able to find the direction of the voice of a person. You can kind of see where it's when it displays a green light, when a single green light, and then when it's trying to process voice, it does like a sort of a multiple changing sequence like that. So now the robot can tells you visually whether it's processing some audio that it's taken in, so you can tell when you should speak or when it's processing and you should not speak because it's already processing. So this really helps in the interaction. So now I'm going to show you the come here behavior and the follow me. So I'm going to go behind. I'm going to go behind him here so that he'll have to turn towards me. Orange, come here. Okay. Okay. And what he does is he turns around to where he heard the voice coming from as quick as he can, as opposed to searching. Then he uses his the Oak D camera to detect where I am and comes up to me. So now I'm going to do the follow. Orange, follow me. Okay, I will follow you. So he uses the navigation, to computes the where you are depth-wise, and then we're using the OD camera, and then plots the location in the or sets the goal location in the nav map. This is using the Slam Tech system, not ROS, but it's very similar in that concept. Part of the heart, he'll back up if he gets too close to you. He'll also rotate his camera. He counters by rotating his camera in the opposite direction that the robot is turning, so that he tries to keep the camera on you. And so I have to add logic in there to do that. So that because the robot is moving independently via the navigation system, and the OD camera is tracking the person via a separate thread of code. So it's the hardest part.
You know, just looking at this as in phases in a run what you brung, I mean,
Coming
to
through
me,
a
it seems
doorway
like
is a little harder. But yeah, he'll do it.
I mean, you're doing the
And he keeps the
room, you're finding the first, and you're listening. What are your future goals for Big Orange?
Now, if I get too close, like I said, he'll back up, and then you can walk around him. The camera will track, and then oops, I confused him. And what happens is that
Getting past 6 minutes.
Eventually the robot will just turn its base so that it will be able to continually track you. So there, he's turning around. Whoop. Ran into the wall there. Okay, and now I can go back somewhere and he'll follow me back.
I'm going to give that an official Floorbot phase 1.
There you go.
When
You
I
got
stop, he'll come up to about 1 meter from the camera to my face, or 1.2 meters.
Hey, Jim, can you hear me?
Orange, stop following me.
Can you hear me, Jim?
Sorry, I don't understand. Stop following him. I also put in this logic to tell you if it doesn't understand, it repeats back. This is very helpful in voice recognition problems. You can also see it on the screen. If I touch the screen here, you can see what the last thing he heard was. But let me. Orange, stop following me. Okay, I will stop following you. And then he goes back into a ready state. So that is the demo. And now I'm going to switch back to my other.
Yeah, that's excellent. Can you hear me now?
Give me a second here.
I know you're having to fiddle with the microphones and the speakers. Can you hear me now, Jim?
Hello, Jim.
Big Orange.
Sorry, I had to turn back my volume up.
I
Any
understand.
Any questions?
Hang on a second before we start to take questions. Chris Mayer's given you an official phase 1 Floorbot, okay? And if I may, you've got a lot going on there, including finding people and understanding voice commands in addition to the mapping and the navigating. What particular plans do you have for Big Orange moving forward?
Yeah, good question. There are a few things, God, I have to find my notes, but I want to state, I do have some things I'd like to improve. For instance, the I have a, facial recognition as well in there where you can introduce yourself to Orange and then he'll remember your face. This is all with the Oak D camera and a facial recognition model. So I want to tighten that up because it has a little slow in the way it reacts. When people come up to something, they want to say, hi, I'm Jim. And then there's all these little delays in robots that due to switching modes and stuff. And so I'd like to improve that.
Okay. Let's quickly get one or two questions in here. I know people want to ask questions. If somebody's got a question, put it out there.
Yeah, other big things are, there's many other things to do, but I've kind of come up to a point where I've gotten most of what I want done until doing what you just saw Scott do, which is put an arm on it.
Do we have any questions for Jim out there, real quick?
No question, but Jim, it's one of my favorite robots. It's great to see it.
Oh, thank you.
Okay.
That's Scott.
All right, Jim Denugio, thank you very much.
Thank you.
All right, moving along with the show. Scott Monahan, you're up next.
All right, give me 1 second to switch my microphone here. Okay, can you all hear me still?
Hang on 1 second before we go any further. Dee Dee and
1 second.
yeah, okay. We need to go back to Jim because we didn't.
Okay.
Yeah.
Okay, can you hear me now?
Hang on a second, Scott.
Hey, I do have a recent photo that from my show. Can I
shoot me the Glamour Shot, or how do you want to do it, Jim?
Do you want me to send you the shot I have?
Send me the shot so that we can include it in our write-up for this evening, okay?
Yeah, sure, no problem.
Okay. All right, sorry about that. Scott Monahan, you're back on.
Okay, can y'all hear me?
Yes. Hear you.
Okay, cool. All right, let me see. Let me share some screen here. All right, so y'all see my robot there?
We see Robot.
Okay, cool. This is Robot. So the idea behind Robot is Robot's the second robot that I've been working on as a project. And I really liked the Anki Vector and some other, friendly home robots that had tried to create an emotional connection and could do all kinds of things. But the problem was that they weren't really commercially viable. So the companies would go out of business and, then you've sort of got this brick that does a few things. And they were pretty expensive. So what I wanted to do was create a bot that was lovable, accessible, and autonomous. So those are sort of my three phases that I'm trying to do here. The idea sort of is to have, a robot that lives in your house, but is like a robotic pet, sort of a cross between a dog and a 1-year-old that is curious and will remember who you are and doesn't want to be left alone, needs to be charged. So it does, needs things from you to get people to create an emotional connection with it. And then on the accessible side, I wanted all the parts to be readily available and the whole thing to cost less than $500. And so Robot can do a lot of the things that Jim's robot does, that Big Orange does. So I don't want to waste time because Jim just showed that stuff. I want to do a little presentation on I know folks had asked questions in the chat about how to make your robot, have a human connection and how to connect to your robot. So I want to do a presentation on how I do the animation of Robot's eyes because people seem to like that a lot. So I've got some stuff set up here. So let me see. You guys see my quad screen now?
Yes.
All right, cool. So let's get Robot. So here's Robot. Now, one thing Robot does, and I think that's really important for like putting eyes on your robot to make it feel like it's a living thing, is to have it blink. And you saw Jim's Big Orange blinks too. And so if you want to put eyes on your robot, make sure that it blinks Otherwise, it's just going to look like two circles and they're not going to code for people for eyes. And another thing that I've learned playing around with robots and eyes and how people react to them is you want the eyes to move with the robot. So if you see, like if as I turn here, you'll see that the eyes actually move the direction that the robot's turning, just like you would if you moved your head left and right. And if I go up and down, it does the same thing. But most importantly, I learned how the Anki vector, the basics behind the Anki vector and how it does the oh, hey, am I Camp? I've got you as the thing. Can you spotlight me? Am I spotlighted right now?
I can see
I'm
all
able
four
to spotlight
screens.
you unless you're sharing video, which you're not doing. You're just sharing screen. So we should be seeing your screen.
Okay. I'm sharing video right now.
Yeah, we're
there
all
we go.
seeing it.
That's nice. That's better. Okay, cool. So anyway, what I wanted to show is how we do these emotions here. And I can change Robot's emotions pretty easily. So here's his base eyes, and then we can make it happy. We can make him ecstatic. We can make him bored. We can make him angry. And we can also like make him skeptical. And I can, of course, like make some changes here and add more. And I wanted to show you how simply I did this with the concept. It was something again, the idea that I had copied from how Anki Vector does it, the same concept. So basically all we've got here is an eye PNG that, is a transparent eye PNG. And then we've got two kinds of eyelids. I've got a square eyelid and I've got a circle eyelid. And I have this set up here to really show you what's going on when I'm doing these emotions here. So if I go here and I change, if I make this happy, you can see we've just got the two black circles just rising up, covering up part of the eyes. You can see that on the top one. And if we go to ecstatic, those circles just move up even higher. And if we wanted to do bored, it's squares coming down. And if we wanted to do angry, we've got the squares coming down and the circles rising up. And last, we've got the confused, skeptical look, and you've got the two squares at different angles. And these expressions are what most people react to when seeing Robot. And I just kind of wanted to show this because I didn't have to do any crazy animation. And I can also control these eyelids basically the same way I control a servo. I can, set them to any height. I can move them around. I can spin this around and do whatever I want. I'm using the two Python frameworks, two Python modules for this. One is the Pygame module, which is it's a nice module that allows you to basically, it's designed to make video games with Python, simple sprite-based video games, and so I'm using that as the display. And then for the animation, I found a really nice library called Tweening. And what that allows you to do is, instead of having all animation just be linear, you can add little effects, similar if you've ever programmed in Flash in the old days, where you, if I move around, you can see everything bounces a little, and it eases in and eases out and gives it more of a sort of a fluid motion that makes it less, less robotic, I guess. But, so that's what I wanted to show with Robot today. Plans for the future. I've got, the lovable kind of down, and I've got I've got it under $500 to be accessible. So those are my kind of phase 1 and 2, but it's not autonomous yet. So I've got lots of proofs of concept. It can recognize people. It does voice recognition. It can do all those things, but I need to tie it all together so it's not me controlling everything and showing it off one at a time. I need to actually make it something that goes around the house and does its own thing. Thanks, Camp.
Yeah, even as you're saying that, Robot's looking a little skeptical there.
He is. Yeah, it's a tough thing. The next thing I need to do with Robot is I'm going to build him a new chassis, because right now this is sort of a proof of concept on a basic smart car chassis. So I'm going to do a full 3D printed custom design chassis for him.
Did you get the Glamour Shot there?
Yes.
All right,
Okay.
thanks.
Very good. Thank you very much. Say,
Right, thanks,
Dilla,
everybody.
thank you very much, Scott. Hey, is Steve okay out there? I don't see him. He's next up. Dillo? Steve okay? Calling once, calling twice?
I've got Bob Allen next on the list.
Let's see, Scott Monahan. Okay, Bob Allen. Sorry, Bob Allen, you're next on the list. Go ahead.
Okay, let's see. We got I guess the last guy is still spotlighted because I see him. Oh, there we go. Cool. So I got my little robot here. It's orange. Camp asked me what the name of it was, and I said, well, it's just a test robot. And he said, well, you know, Jim's got big orange. Why don't you call it small orange? So that's his name. I've got a short little video that I would like to run and kind of explain it. So let me share my screen. Let's see there.
Hey, Bob, I believe I said little orange, but if you do, you want to go with small orange or little orange?
Oh, little orange is fine. Yeah.
Kumquat or something.
Yeah, really. Okay, let me get this started here real quick. Hang on one second. Push the wrong button. Come on. Well, that didn't work, did it? Well, you know, you get everything lined up and then it goes away on you. Give me one quick second here and just restart it. Okay.
This is my small Lidar robot I use for testing. It's all 3D printed. It has a 10C 4.1 custom board that I designed for it. Some power switches and a meter, and it uses Bluetooth. This is the bottom of the robot. You can see where the batteries are, motors, IRs. This is the cover, kind of keep the dust and dirt off. This is a view of where the switches are for the bumpers. The bumpers are moved into the center of the robot. This way they're away from the bottom. They don't collect dirt. They don't get damaged. And I've been finding this is working really well. This is my custom handheld remote. It has a 10-inch next-gen display with a 4-axis joystick. And I use it to control and get data back from all my robots. I 3D printed the case. And it makes for a really nice way to get information back from the robots. I've started the robot and it's moving, and you can see the status line that you see cruise active, Lidar active. That's the behaviors that's actually going on. Now I'm going to go ahead and set the bumper behavior, and I'm going to go ahead and set the bumper, and you can see now that the bumper has been activated. It's going through its bumper routine. And then also have indicators that show when the bumper has been hit. In this case, the left one has been hit. And it's going through its bumper routine. Now I'm going to go ahead and deactivate that behavior and hit the bumper. And you can see that the no bumper lights come on and it's going through its routine. Here is, again, the front of the robot. I'm going to select radar. And the radar is being updated from the Lidar. I call it radar. And that's really helpful in debugging. Here, I got my robot going around in my perimeter firefighting house that we use for firefighting. And this is, I think, about 4x speed. And you can see it kind of slows down, turns rather fast. But this is all the LiDAR that's making him avoid the walls. I actually take a look at 20 degrees in the front, at 45 degrees, about 10 degrees, and 90 degrees, again about 10 degrees right now. And I do it for the opposite side. And it's okay. It needs some more work done to it. This was just kind of the first start. And it's still in the development stage. It's a lot of data that comes through, and trying to manage it, makes it a little difficult, but it's seems to be working pretty good. It's avoiding all the walls and running around the room pretty good. Eventually, I'll put some more walls back up and some more objects and use it for complete testing and to make sure that LiDAR is seeing everything. And we get over here, I think, into the corner, and we actually use the bumpers, and then he kind of hits the wall, and kind of get.
Hey, Bob, is that using the Slam Tech software?
No, that's all software that I've written. So
Very
it's
nice.
all it's running on a Tinsy 4.1. So I've written all the software, and I'm using the RP LiDAR library to actually get all the data from the LiDAR, and using that then. And the difficult part is kind of breaking up all the different angles so you can look at different things. I did that on my sonar, which has 16 sonars on it. So I'm using kind of the same procedure. And I break up everything into color zones. And
What kind of board are you using? Teensy?
It's my own board that I designed. It has a Tinsy 4.1 on it, and it's all custom design. Did that, and everything's 3D printed.
Very nice, excellent. Bob Allen, ladies and gentlemen.
Thank you.
All right. Thank you very much, Bob. That's awesome. Next up, Steve OK. Steve OK, are you out there? I don't see you. Dillo? Hey, Bob, let me come back for a second. Did we get the glamour shot, Dee Dee?
Yeah, there's pictures of him with the robot.
Hey, is the robot local there, Bob?
Yep, we got it right here.
Can you pick it up inside your head?
Yeah, let's see. Let me back up a little bit.
We're looking for work it, baby, work it. That's good.
All right. Okay, great.
Sorry, I missed it. Can you do it again?
Yeah, can you spotlight Bob?
There we go. All set?
We set?
Yes.
Thank you. Thank you.
Thank you.
Okay, I don't believe Steve OK or Dillo is there. So Dee Dee, you're up next. Let me spot.
Okay, I'll share my screen.
Oops.
Okay, so here we go.
Your spotlight is.
Is it not sharing the right screen?
I see you with the in moves.
It's the video.
I tried to share a screen. Yeah, robot comedy show updates.
Yeah, we see the video.
Oh, great. Thank you.
Volume is a bit low. Can't hear it. You might want to make sure you share with the audio or turn up the volume.
Let me see. I'm having trouble finding. Oh, here we go. Share sound. Thank you. Okay, I'll rewind. Is that better?
Hi, my name is Damari
Yep.
Stevens, and these
Great, thank you.
the robots I've been working on this month. I'm getting ready to release robots for the Robot Block Party, and I made a couple updates. So I updated its voices to eSpeak, and so it's connecting well with the others right now, and I'll put the voice on very soon, but it's still selectable. We have hi, just joking, knock knock jokes, who's on first, and poetry jam. We have our 3 image. My daughter built this when she was 12, and then I built this one, and then my daughter built most of this one a couple years later, and then last year I added this screen over here. So I'll turn on the sound so you can hear it talk.
Hello, how are you doing? I am doing fine. I am in mood. Really? Are you serious? I am in mood too. So cool. Wow, that is awesome. We were both designed by Gail Landibin. He is from France. Yes. We were 3D printed by our family in California. The Davis family. Lauren Davis built her first in blue when she was 12 years old. So cool. I love to tell jokes. Really? Me too. I love jokes. Why did the robot go back to school? Because his skills were getting a little rusty. Was that funny? Ha ha ha. Here is another joke. Ha ha ha. Here is another joke. Why did the robot cross the road? It was programmed to be a chicken. Was that funny? Ha ha ha. Oh yes, this is so awesome. It's like a robot family reunion. What do you like to do for fun? I'd love to play with bright lights, make fun things, and get inspired by art. I'd like to hang out with my robot friends that dance and look at the interactive tree of lights. I hope everyone has a great time at the Robot Block Party and gets inspired to make your own fun projects at home. Yes, please make more robots so we can hang out together. We will try our best to not take over the world. We will promise. Have fun while you can. Yes, have fun while you can.
Really like those in-move robots. They're fantastic.
Thank you.
Need to work on the comedy a little bit, but the robots are fantastic.
For that, I blame my kids and Google.
Okay, we're hard to impress, but easily amused. That's very, and the Robot Block Party, April 2nd at, what do they call that place? The Circuit launch?
Yeah, Circuit Playground.
Yeah, Circuit Playground. Okay. Yeah, that would be a lot of fun. Folks, go to that Robot Block Party, April the 2nd. Thank you very much, Dee Dee. Do we have any questions for Dee Dee? Thank you very much.
Okay, thanks.
All right, next up. Sergey, I think you're having trouble with your electricity, weren't you? You still there? Anybody seen Sergey? I think he may have called it a day. Thomas Metzer Schmidt and life-size biped. Run what you brung. Thomas, you're on.
Yeah, hello. That's my biped there. I got a new camera here. I was trying it out.
Like you.
Can you hear me okay?
We can hear, oops, I'm sorry, I didn't mean to ask you to unmute. Can you, there you go. And okay, you are spotlighted, go ahead.
Yeah, and it works really well. And then a wire got pulled off of it somehow. And so I only have a video to show. so I'll show the video.
Nice, you've got the backup video, otherwise it didn't happen.
That's right. All right, let me start the video here. Okay, let me cue the video and then I'll share my screen.
Thomas is the president of the Riverside Robot Club, right?
Yeah, we meet once a month, the week after the Robotics Society of Southern California. And a lot of the people are members of both clubs. We have people jumping all over California. And I'd come to the Northern California club meetings as well in person, but my wife doesn't want me buying so many plane tickets.
I always drive, but it's a long run.
It's a long drive. I used to work up there. I would drive back every weekend.
Oh, okay.
All right, here we go. Can you see the robot?
No.
No, we're seeing
the wrong screen. Maybe.
Black screen. It's a screen with slashes, with diagonal slashes.
Really? All right, well, let's try again. How about now? Do you see it?
Yeah.
All right. So, by the way, this thing runs with these, what is it, 60 kilogram centimeter servo motors. And, it uses 4 of them. And it stands about 25 inches tall, which makes it, if that's somebody's crotch there, that makes it almost a small human size, probably the size of my mother-in-law. She's kind of short. So, and I learned something on this, that when you have a biped and it's walking, humans have a top half and we lean as we walk. And so without a top half to compensate, I had to lean these legs way over. And that's the next phase, will be adding a counterweight or a top half of the robot.
You put Simone on them?
No, this is my Bigfoot 2, the human-sized bipedal robot. It looks like its first steps. I've assembled it all over from some extruded aluminum channel. And we've got it balanced really 60 kilogram per centimeter servo motors. And of course, the easy robot board and simply.
Yeah, Thomas, could you put a link to the servos that you're using in the chat, please?
It's kind of clumsy. Yeah, they call them robots. They have all that days old. Those things, still a lot more coding to do. And yeah, it didn't fail because I very well. And that's not my robot, that's an animation. I want to show you the latest, second robot. I want to show you the latest robot I've been working on. Cue it up. I know that guy. So there it is. over at the Robotics Society of Southern California, every so often we do a robot get me a beer contest. So this robot was, I put it together with that intent. I also bought an Oak D. So in the meanwhile, I have had the Oak D running, and then I had to figure out the math to locate the actual bottle. Here it's a bottle of Perrier, an empty bottle of Perrier. So when I get it all together sometime next year, maybe I'll have the whole thing together and I'll say, robot, get me a beer, and it'll find the beer and hand it to me.
That's awesome. Hey, can we get the glamour shot with you and the biped?
Oh, can I share my screen, or do you see it or you don't see it?
Well, I see the screen with your beer robot.
Okay, let's finish it up and then I'll give you the glamour shot. It's got 10.
Take not too much.
Please take it.
Robot, I've got it.
Here is your beverage.
And there you have it. It worked. Yes, it worked, but it was pick and place. It didn't know where it was. It just went to the location where I taught it to go to. All right, that's it. Sure, we're gonna stop the share.
Well, that's an official Robot Arm Challenge Phase 2.
Okay, there we go. I was gonna say an arm challenge.
So what's phase 3?
Chris,
what's phase 3?
Location and place it in a container.
Oh, place it in a container? Well, that shouldn't be much harder. All right, so I guess I'll do it like this.
That. Do it in June, okay?
June, is that my deadline?
Yeah, that's your phase 2. Oh, that's your phase 3.
Phase 3, okay, June. I'll make that my target and my deadline. Okay, here we go.
2, right? Get that glamour shot. He got phase 2, right, Chris?
Correct. Phase 2.
Okay, cool. And you got the glamour shot there, Dee Dee?
Yes, I do.
Okay. How about a glamour shot with the biped?
Okay, that's a little harder. It's on the floor. Let's see. Let me aim the camera the other direction.
If you can do
it out of the way. Yeah, there's in the back.
We're trying to see the biped, right?
Yeah, I'm trying to see the biped. I gotta move the stuff out of the way.
Oh, I see it now. There we go.
Pick it up.
We got to see you there. There you go. Can you kneel down a little? Can you be a little? Oh, there we go. That's a good shot. All right. You got it, Dee Dee?
Yeah.
All right.
I'm sorry, my screen crashed.
Stop. Got it?
I got it.
Maybe they give me a better.
Okay, thank you.
Will somebody else get it, or do I need to pose again?
Someone else got it?
Yeah, we got it for you, Tom.
All right, sounds good, guys.
Moving right along. William, plank on the wheels. You're up. Run what you brung.
Oh, hello, can you hear me?
Yes.
Okay, good. So, this is what I was working on over here. Oh yeah, by the way, this is my first time being in the Robotics Homebrew Club. I probably said that backwards, but nice to meet you all. Yes, so this is the robot, and it is basically just 2 motor wheels and a training, and it is running off of an ESP32 camera. And what it's doing is it's able to, it can move over internet and just push the cart around, and you'll have like a video stream and you can move it with the joystick. So I guess I'll try and get that running right now. Give me 1 second, I gotta put the battery on. Okay, I'm done. Let's share my screen.
Where are you located, William?
Oh, I'm in San Jose.
Fine.
Yes, I'm John Sokol's son. Okay, so can you guys see the screen?
Yes.
That's good. Let me close this. Okay, it was working 10 minutes ago. Let's see what we got. You know, I got a video on YouTube that I can get running. Yeah, let me try and just get that one. Okay. Do you see this?
Yes.
Okay. Yeah, so this is what it's supposed to be doing. I was doing this like 10 minutes ago. I'm just gonna try and get that running off screen.
So is this Wi-Fi or is it all the way through the internet?
This is using LAN Wi-Fi. I am able to get it working off of like a server and streaming it over internet for real, but this is just like the prototype.
Very cool.
Oh yeah, the camera is wobbling that much because it is on concrete and it's being held up by wires. So that's just a mess there, but
See John back there.
yeah. So one of the goals I have for this is to get rid of the training wheel and kind of act like a hoverboard. And I think that's going to be a pretty interesting goal. And I also want to make it so that you can connect from anywhere on the internet. So for instance, you guys could try and connect to it. So those are kind of the goals I'm going for with this. And I'm also trying to make it really cheap because I actually want to sell this. So I'm going for roughly, I want to sell it for $120 to $80. And I'm currently using $40 in parts. So yeah, I just kind of wanted to get some, oh, what is this? This is just a random video. Okay, so yeah, that was kind of what I have. I wanted, I was hoping to get some thoughts. So what are you guys thinking?
We have show and tell every month, so come back and show us your progress, okay?
Oh, do you have
Made a jump for-
yeah, my computer's not putting out any sound right now, so
we have show and tell every month. Next month.
Okay, let me kill my
And say hello to your dad for us.
Yeah.
All right, let's do it. Let's do it on my screen here, William. Because it's this setup, so
Can you swap to John Sokol's screen?
here, come around this way. I should be unmuted.
Yeah, okay. Can you guys hear that?
We're still viewing your screen, William. Okay, there you go. Now I got my mug.
Okay, highlight. Okay, highlighted now. Go ahead.
Okay, yeah. So I have roughly $40 in parts right now.
Grab the thing.
Trying to make it.
Watch the battery.
Trying to.
So this is just really quick and dirty. So this is like a cell phone box. We just put a caster on it
Yeah.
And two wheels. This is literally the Mopbot motor controller. So this is pretty much a Mopbot. And then above it though, we replaced the Nano with a ESP32 camera. And we're going to put an IMU on that and then try and balance the whole stick eventually here. And there's a USB to serial converter for programming it.
Okay.
This little red board.
Plank on wheels. Can we get
Robot. Yes,
Whoop.
there is. Training wheel.
up there?
Huh?
Can we get a glamour shot?
Oh.
Glamour shot. Then back up, William.
This is close enough.
Oh, that's the battery.
Yeah.
You need to be a little.
No, go that way.
Scott, you got it?
Yeah.
You gotta lift up. Okay, I'll get it because
Scott, you got it?
Okay, good.
Okay, all right. William and John Sokol, plank on wheels. Thank you very much.
Okay, thank you.
Keep it going, so bring it back and let's see some progress, okay?
Yeah.
Kevin Chow, you
Yep, I'm here.
you're on.
Yep, let me just unplug my thing. It's on charge right now. Hold on.
I got you spotlighted. William, Kevin Chow with red. Scott, have a good evening. Had fun, thanks.
Right. So this is my
Let's get the glamour shot, DD.
yeah, hold on. Let me just back up a little here.
Yeah, there you go. You got it? DD Scott?
oh, that's awesome.
Okay, Kevin Chow and red. Go ahead, Kevin.
Yeah, so basically just a quick yeah, just to say just quickly what's on here. I got like a Hex Bug Spider XL. It's a kid's toy, like it's and mounted on top is basically a Raspberry Pi. It's actually like not a Raspberry Pi bare bones, but like it's like stuffed into some other thing. It's called a Pi Top. That pretty much gives it like a internal battery and stuff, and a bunch of other features. And as a motor driver, some batteries for the motor driver and an OP. So yeah. And as for what I'll be, I guess I'll be showing, I'll just have it like kind of spin around, and when it sees like a bottle, it will try to go towards the bottle, basically. Yeah. So
Can you hold it up again? I'm sorry.
Oh yeah, no problem.
Great, thank you.
Yeah, no problem. So yeah, let me just put it on the floor. Actually, let me get just take a minute to get my other camera real fast, so I don't have to like hold my laptop in a weird position.
Live shows are rough. But I think we've done pretty good through it.
All right, so let me just find a good position to actually put this camera. Hold on.
Yeah, we've gone through a lot through in just 1 hour or 2 hours. Okay, 2 hours.
4. Yeah. Yeah, it's a little cameo from some of my startups robots, like in the background there. And just start a few scripts. Right, almost ready. All right.
Looks like something from Toy Story.
Yeah, and
you're off screen.
Sometimes it kind of gets stuck a little. Like, yep.
Right now, Kevin.
You're still off screen.
Yeah. Yeah. Let me just. All right. Back. Yeah. Actually, I'll hold the camera by hand. Actually, maybe that might be better. Okay. All right. Try this again.
Where's the bottle?
Yep. So that's pretty much it.
In the bottle?
Yep. Oh. Yeah, sometimes it gets stuck because I guess the weight caused it to strip a little bit or something. So yeah.
What's the next phase?
As for the next phase, I was thinking of like getting like I guess maybe it like follows the bottle or some other object a bit better, and maybe like tries to, I guess, maybe touch it or push it or something. Yeah, either that or if I get like another idea, like
yeah, find an object or fetch an object, that gets into the Floorbot. Thank you very much, Kevin. That's awesome.
Yep.
What kind of processor does that have?
So just basically a Raspberry Pi 4.
And that the camera, was that what I saw there?
Yep, it's a Oakley camera. And right now I'm just running one of the example code.
Probably need to get a bigger,
slightly modified to send commands to the motors. But yeah, it's basically just running the example for the mobile net SD or something like that. Yeah. And the reason I chose a bottle was because it was just one of the predefined objects that were already there, and it was kind of simple.
Very cool. All right.
Is that an Oak D Lite? And which version of Ubuntu is on the Pi 4?
Oh, yeah, it's an Oakley, like a regular one, not the light one.
Okay.
Because I don't have a Oakley Lite, at least not yet.
No, that's okay. And then the Ubuntu
yeah.
version.
And as for the Raspberry Pi, I'm actually not using Ubuntu on this because
Raspbian.
Yeah, I guess it's a kind of a modified or forked version of Raspbian, sort of.
That's okay. That was the question. Was it Ubuntu? Thank you.
Yeah.
Thank you very much, Kevin. That's awesome. Thank you for sharing. All right, George Taylor, you're up next.
Okay. So this is a.
Let's get the Glamour Shot, Edie.
Okay, let's see. Let me get this up. Let's see. Yeah, that's the right direction. Okay, how's that? Okay. This is basically a robot that I saw in Structables, and I thought, oh, that's a cute. It's really supposed to be built on about a 4x3 printed circuit card, but 3 high. But I decided to do just a breadboard of the whole contraption. It'd be easier to check out all of the items. So it's a balance robot. You can see just 2 wheels, and it uses a Arduino Pro Mini, a 6050 MPU, a 8833 motor driver, and the ping unit that's here. And notice I put training wheels on it because it's a balance bot. And I'm down to the point now that I have it all, it's all functioning, but I'm down to trying to figure out how to tune the PID. And I've been able to successfully come up with a program that allows me to get the parameters, set the parameters for the MPU. And at this point, I can actually, let's see if I can, I can turn it on. Maybe you can see it, try to okay. You can see I've got you can tell that the MPU is working and the accelerometer and the gyro are actually providing information. However, currently it does not balance.
Are you trying to make a balancing robot here?
Oh yeah, 2 wheels, how else, right? See, the training wheels are just there to catch it when it doesn't balance.
Okay.
While I'm trying to work it out. Now, some of the questions I have, maybe you can, some of you can give me some advice. One is trying to make this thing work with this much more mass, since this is all supposed to be on a 3x4 footprint. Do you think that perhaps my mass is so large that I'll never figure out how to make it balance with this configuration until I lighten everything up?
Actually, you want more mass higher up. You want it to be more unstable to dynamically balance. The problem is these yellow motors have an enormous amount of static friction. So you're almost like 50% power before they start moving, and then they take off on you. So they don't have fine motor control. I did manage to get the Little Bot project, which is in my GitHub repo. I have a mirror of it. I did get Chris Haycom to put it online. The balance code that I managed to get working for his Little Bot, which was an MPU 6050 and with the exact same yellow motors. And like I said, balancing on those was brutal.
Okay, that's a thought, because I could, yeah. Okay, now what if I mount? You think if I mounted the battery up higher, that would give me the upper mass that I would need?
Well, we're about to, balance basically the stick here very shortly, and we're going to do it on the ESP8266, which is, or not the 8260, the ESP32. Our biggest problem so far has been the video conflicting with the I2C bus and things like this. So I think we're past most of that. If it was just a straight Arduino, I would have just dropped the Little Bot code there and just adjusted my PID and been done with it.
Yeah.
John, can you post your GitHub in the chat?
You want me to pull it up?
Yeah, my son will put it up.
Okay, but just do you think the idea of putting the battery up here, let's say, above, so that the mass of the battery would be higher?
The Antibots ended up being about 30 pounds on the wheelbase and 10 pounds at the top of the mast, which was like 2.5 feet to like 6 to 9 feet up.
Well, this
in this case of these short robots, do I have the Little Bot video here? You could see maybe. you know, the batteries are up high. The problem is when this hit, the batteries would explode all over the floor, which made for interesting tuning. And then the other biggest problem we had is the I can't see my own video, which kind of sucks. Oh, there it is. Okay. The MPU 6050 was mounted right here, and so the board would flex on impact, and that would be right where the MPU 6050 was, which was our most delicate, was it QFN package or whatever. So it would actually kind of bend the board and detach the one chip that was most sensitive to flexuring on the board.
Yeah, well, I don't have that problem. But anyway, it's a fun project to play around with.
Just put a mast or a stick up. I wouldn't raise your batteries because then they're going to scatter when it tips.
Well, I've got training wheels, so I don't have that problem.
Yeah, so I would maybe put like a broom handle or something on there. So just increase the, okay, think of it this way. A longer pendulum handle has a lower time constant.
Right.
But you don't want enough weight that it's going to like fall, right? So, you know, just put a pendulum handle on it, basically. Just, you know, a thin stick with a, you know, a weight on it.
Oh, that's a clever idea, because the mass of the pendulum doesn't make any difference, right?
Thank you very much.
Okay,
yeah.
great. Thanks. Okay, thanks.
And hopefully we'll see the pendulum back.
You bet.
Doing some telepresence. All right, last but not least, Dr. Alan Fetterman and the Magna robot. I think you've got a big announcement, right, Dr. Bot?
Yes, indeed. So I'll send you the Glamour Shot. I'll send you the, I've already sent this to you, Cam, so you can forward that to them.
Can't do a glamour shot if we don't see your face, Alan. There you go. Nice.
Okay.
That's the best we got.
Sorry, my computer's slow. I'm gonna have to ask you to do that again.
I have the oldest
Thank
laptop
you.
in the world with the worst camera.
Oh, that's better, but you have to wait for me to save the previous picture.
You're up to something. You like the cat that ate the canary or something.
Okay, that's better. Thank you.
Okay. So I'm going to share a screen and hopefully show a video that I recorded just mere hours ago. Goes nothing. I am taping my demo of the Magna Beta 2 Noetic image, just released today to the public. I'm not using my fiducial navigation. I am demonstrating everything else. Here's the robot in my room. Here it is up in RViz. Here is my joystick controller, so I can drive the robot forward and backwards, rotate it around, and do the same thing in RViz. Rotate it around. So now it's looking at the wall. Yes, indeed. And the mostly the Lidar and the sonar sort of agree. You sort of have this weird arrangement of redundant sonars to sort of catch weird edge. So we have 1, 2, 3, 4, 5 sonars. Lidar in the center. And we also, on this guy, have more display information. So we actually do have a screen and a keyboard attached for debugging purposes. And if I slowly get around, here we can actually have an OLED display that tells us what's going on. Interesting.
What
though.
is an OLED display?
Let's see if how long it takes for.
I'll
yeah,
tell you in a
motor
minute.
power off
No,
to
no,
register.
it's me, Alan.
Takes a little
Mark.
while to time it, so you can actually do some debugging if you don't have a screen. And so here's me saying, bye-bye. Okay, so we released this beta today. I sent the link to the HBRC mail list. So this is a Ubuntu 20 Noetic release for the Raspberry Pi. We'll work on Raspberry Pi 3 and 4. Caveat, it is the ARM32 version, not the ARM64, because what is it? On the camera, we're using a Raspicam, and it doesn't have support, or there's problem with the support in ARM64 for the motion vectors. And we don't use the motion vectors a lot, but what we do use it for, that's essential for our use, is when we do fiducial navigation. And we have to have that to support past customers. But that's it. Also, the LiDAR that I'm testing here is a more expensive LiDAR. It's the Lishan N301, which I guess they say is a 20 to 50 meter range LiDAR. And it requires a little more overhead because it's on Ethernet than something like the little RP LiDAR, LD LiDARs, which are like maybe $150. This one's a little more expensive. Any questions?
Yeah, I posted a question about this, whether sonars are, you find them really necessary or not to have good navigation. I noticed
if you have a LiDAR, the sonars are like not very useful.
Well, actually, I beg to differ slightly. The sonars have a 60-degree cone, so they are for collision avoidance, not for navigation.
Ah.
The LiDAR is like a flat plane, and you're going to miss anything below the LiDAR or above it.
Ah, so you're saying because of the cone, this is a fundamental thing I've been interested in, because of the cone nature, even if the sonar is at the same level, theoretically, which it wouldn't be, but it's going to see a little bit above and below. That's an advantage.
Yeah, the sonars are like a thin 5 millimeter thin plane throughout the room, whereas I'm sorry, I said the LiDAR, whereas the sonars branch out, and so you know nothing's perfect. You just get more. That's all.
Yeah. I just found maybe I'll try turning mine on, but for some reason that data made the robot kind of have difficulty getting out of tight spots because the sonars would pick up the walls, and then the robot didn't think it could move anywhere. But that may be a different problem with the SlamTech.
We can talk later if you want. Sonars have their own evils in that reflections come back to it, and it may think something is farther away when in fact it's actually near an angled wall. Anyway.
Oh, so yeah.
So you can
Anyway,
see
yeah.
that. Mark, actually see that in the video, that the straight-on sonar saw the wall, but the ones that were angled had no idea where the wall was. That's why we have 5 of them as opposed to just one.
All right. Dr. Bot, Alan Fetterman, thank you very much.
Camp, do I have a 30-second spot here?
Go for it. Mark Johnston, ladies and gentlemen.
I've already shown this, but since segues came up, this is the thing that I posted a video on, and the weight is indeed up high. And it's got an ESP32 running the show and some small stepper motor controllers. So in fact, this is using stepper motors, and that gives you some advantages in terms of your complexity of the PID loop and so forth. So anyway, that's it. It's just got it also has IMU, of course, to balance. So that's it.
Hold it right there, Mark. Dee Dee, get the Glamour Shot. You got it? Dee Dee?
Yeah, one more time.
What's that robot's name, Mark? Mark, what's the robot's name?
I'm finding it really hard to smile forever.
Okay, it's okay now. Thank you.
Anyway, this is Balboa Bot.
BAL, BOA?
Yeah.
Oh,
Is
okay.
that like the
A little more interesting than just Balance Bot.
is that like the park in San Diego?
It's just that I thought that he was a fine explorer. So yeah. Anyway,
Oh, okay.
He's a navigator.
navigator, yeah. All right. That's it. I wasn't planning on doing any kind of demo or nothing.
Ladies and gentlemen. Okay. Who else? Does anybody else have a robot to show out there? Going once, going twice. All right. That's 15 robot builders and 18 robots. This has been one fantastic meeting. I'd like to thank everybody for coming, and especially those who have participated. We have show and tell every month, and we'll do this challenge meeting again, phase 2 and 3 in June and October. There's the robot party. Sign up for the robot party on April 2nd. At the circuit launch. I think there's a link in the mailing list, and thank you very much. Anybody else got anything else?
Yeah, I believe the phase 3 challenge is in September, not October.
Thank you for that, Chris. In September. Thank you for that. All right, I make a motion that this meeting be adjourned. Do we have a second?
Second.
Okay, second. All who agree say aye. Aye.
Aye.
We'll say nay.